next up, as I just said, we are going to have a presentation from Randy at Hashmap. Randy and I have done a number of things together here over the last couple of months, including I had the honor of having Randy interview me on his podcast about my life and times here at Snowflake and data and all sorts of really fun, interesting conversations that we had. But Randy has been writing all sorts of blog posts. He creates, video podcasts. He does a lot of how-to webinars on the Hashmap site, talking about Snowflake and integrating Snowflake with a variety of tools. Today, he is going to take us into a bit of a deep dive on streams and tasks with some example scripts and demos, and maybe some of you out there in the virtual land here may want to even follow along. So introducing our data hero here from Oklahoma City, Oklahoma, Randy.
Hey everyone, thanks for joining today. Let me share my screen. We can get right into it. Hopefully everyone can see that.
Yep, it's showing through. Yes, it is in presentation mode now.
Awesome. I'm going to show this link here. I'm a big Bitly fan, and if you're interested, you don't have to. It'll still be, I think, hopefully useful if you don't. But this is the link to the script for today. So if you type in bit.ly/Netflix streams and tasks, this will take you to a GitHub gist page where you can grab the SQL and then just jump into Snowflake, and we'll work on that. But first, let me do a bit of an intro. My name is Randy Pitcher, and I have wanted to do an intro slide like this, I think, for years. And I've never really had the right audience where I think it made sense. So I'm really excited today to have a SQL statement to introduce myself. I'm technically a regional technical expert at Hashmap, but I'm not really regional anymore. And what this means is different to who I'm talking to. So today I'm just a developer, but sometimes I'm a sales engineer, and other times I'm a Snowflake admin at Hashmap, which is the coolest company. And I have definitely, I think, the best job in the world. All my friends hate me for how cool my job is. I have been a Snowflake user since late 2018. So being in consulting, I get the benefit of using lots of tools. And Snowflake just fell into my lap, and I'm so happy that it did. And my favorite Netflix show is BoJack Horseman. It is definitely an underrated show because people think it's just a goofy cartoon, but it's not. And this will come back later, so I'm not just sharing personal facts. But let's dive into what we're going to actually talk about today. I want to talk about streams and tasks. And we noticed in the transformation section last time, people asked if these are things we can consider for transformation in Snowflake. What I notice often is that people are a little confused about, especially streams, like what is a stream? Why are they really cool? And how can I use them? And then tasks, I think those make a little more sense, but there might be some things to know about them. We'll then move into the hands-on lab, which is a totally made up scenario that I have about Netflix. And then I'll leave you with some closing thoughts, and we can do questions. So definitely ask questions throughout, and yeah, let's dive in. So Snowflake, I think a lot of people are familiar with it for its data transformation, its SQL capabilities, but how can you use it for continuous processing? So first thing is streams. And I am not going to read the docs explanation of streams or go under the hood on how they work. That's really interesting. And I would recommend going to check out the great Snowflake docs on this topic. But I want to provide like a gut feel. How do you think about streams? So first, they're really similar to processing queues. So I think when people hear processing queues, they might think of Kafka. You could use RabbitMQ. You can use any kind of queue structure. But a queue is just a place you put work that needs to be done, and then workers to do that work will pull from that queue instead of pulling directly from where the data is. So streams, think of it that way. That's the best way to really work with them mentally. They're queried like a table, which is so, so cool. So if you are working with Kafka, for example, you have data that needs to be processed, you probably have to have some mechanism to pull that data out and parse it with some potentially Python or other languages. And even with the Snowflake Kafka connector, there is some amount of like DDL to be done. But if you have a table that's just getting updated regularly and you can create a stream off of it, you can query the exact data from that table plus a ton of bonus fields, just like it is its own table. So stream A here, I select star from, I'll get all the data, all the columns from my underlying table, plus some bonus ones. We're going to talk about this a little later. And they're really useful for efficient CDC processing. Oftentimes you might have a table that's too big to fully reprocess. Every time you need to update data, you get new data. And it can not always be the simplest thing in the world to find out which data in this table is brand new, especially if you have updates hitting that table. So streams make it really easy to grab just the new data so that you have more efficient processing and you can maybe even process more frequently. If at this point you're still like, I don't know what a stream is, that's okay. Streams resist understanding until you actually get your hands on them. That's just kind of the nature of streams, and I think it's why docs and charts don't really convey it. We're going to explain this better in the hands-on lab. Next are tasks. I think these are a little easier to maybe wrap your head around. They're just scheduled queries. So they're kind of scheduled like cron jobs, where you give them a schedule and they will run on that schedule. They run a single query. So if you need to do something more complex, stored procedures are encouraged, but you can also chain tasks together. So if I have a task for loading data, a task for transforming that data, maybe doing some data quality checks, and then a task for processing that data, I can have those all chain after each other. So when the load is done, it triggers my flattening and cleaning task, and then that triggers maybe my data quality checks task. But they can also, you can just bundle that all together in a single stored procedure and use it that way. So these are the main components we're going to work with today, and let me lay out the scenario a little bit. So I am a huge Netflix fan, not just the content, but the data engineering, and I'm pretty sure Netflix has spoken publicly about their Snowflake usage and the things they do. So I thought it would be fun to come up with a interesting use case for like quote unquote Netflix data. Our scenario is that we have streaming data coming in and it's semi-structured. So it's kind of in a JSON format and it's just event data. It arrives continuously. It's just constantly coming in. It's getting loaded, maybe with Snowpipe in our scenario. And our problem is we want to build a ratings table. So some of this data includes ratings from devices. And you can imagine like we have cell phones, tablets, we have Chromecast, laptops, all these different devices just streaming tons of event information into this space. So we want to grab just the event data we care about and maybe combine that with a reference table that has a bunch of metadata about individual Netflix shows, because for event IoT kind of data, you want to make that package as small as possible. So you'll use like a show ID. And the question is, how can I process only the new review events to create a show reviews table with show details from that reference table? Basically, how do I build an analytics-friendly view of my streaming events of rating on Netflix, right? And I know they have the thumbs up, thumbs down. In our scenario, we're going to maybe use a 10-point scale and compare that. And again, you can check out bit.ly/Netflix streams and tasks, and that is where our code will be. So I'm going to jump out of my slides here. We're going to go off-road. And if you clicked on this, this is what it looks like. We have just a few fields that we need to fill in. So you'll need a role that can create a schema in a specific database and can use this warehouse. Other than that, you should be good to go. So if you wanted to copy this, go to raw, control all, and copy. I already have mine pasted though, so in here. And I filled in my specific roles. So RTE, remember that's my job title. I have a dedicated warehouse for myself, and I created a database the other day for Snowflake Group By. So that's right here. We're gonna run through this line by line. So if you don't have Snowflake up, don't feel like you're missing out. I think you'll still get value out of this. So first thing we're going to do is set our context. Hopefully you've had a second to fill this in. I'm not leaving you too far behind. And so I'm going to use role RTE, warehouse RTE, and then use this database. If I refresh here, the database is empty right now, just an information schema. It technically has public in there, but my role doesn't have access to public. And we're going to start creating some tables. So these are the 3 core tables we care about for this scenario. The one is just the events. So they're called rating events, but we have kind of a mix of things coming in here. And they're just going to be a variant type. Okay, let me use schema. So hopefully for you, you didn't have to have the or replace where it would lose that for you. Oh man, of course, this is my nightmare. Oh, did I not create it? Excuse me. Okay, so now it exists. Let's create or replace this table. Great, and if I refresh, I should be able to see this Netflix streams and tasks schema and this table, the Netflix rating events. So it's just gonna be raw data variants, totally unstructured, no schema here. And then we'll create this Netflix ratings table. This is our end result table where we'll have the show ID, the title for the show, and then an actual rating. So over time, we could build out some kind of dashboard that will show us the best show on Netflix or the most highly rated show. And then the last table here is really our metadata table, kind of a reference table for Netflix shows. And this will take an ID that we have maybe from our ratings events and then give us the title of a show. So if I refresh over here, we can see we have Netflix ratings, Netflix rating events, and Netflix shows. First thing I want to do is fill in this reference table with some shows. These are shows I like on Netflix and giving them some IDs. I did want to point out BoJack Horseman actually is the best show on Netflix. So that's interesting to know right up front. And we'll experiment today to see if it's also the most highly rated show on Netflix. So we created that, and if I just take a peek over here at Netflix shows, we have 7 rows, and in a preview, this is what the data looks like. We have these IDs and the show title. So next step, let's create some streams. So remember, we're here to learn about streams and tasks. And I have found by far the best way to learn about streams is to create 2 of them and screw around with one of them. By seeing how stream A changes compared to stream B, you're going to start to get an understanding of why these are useful and why they're powerful to use. I also want to convey, like, streams, they're not scary. They're not as scary as they seem. So if you have tables that change, go ahead and create a stream on top of one of them in your own time. And then you can play around with that stream. It will not impact the underlying table that you're working on. And it won't duplicate data storage. There's some additional data storage for the metadata, but you can create a stream and play around with it and get a feel for it without breaking your existing pipelines. So I'm gonna create stream A and stream B. And then I'll use this nifty command to basically just list my streams. And here they are. They're both in the schema. If you're not familiar, they won't actually show up visually here. So you'll wanna get familiar with the show family of commands. And great, they work. They're delta types. There's a lot of configuration you can do on top of these that for your specific use case is worth checking out. So go ahead and look at the create stream documentation for your specific use cases. So let's start modifying some tables. We created this on top of the ratings event. So right now, if I just select star from A and B, they're empty. Perfect. And you'll see that the schema, though, has raw data, which matches exactly our ratings schema. Sorry, rating is events schema, just raw data. But we also have these metadata columns. The action is update and the row ID. So let's go ahead and insert some data. And I'm going to insert a rating. This is maybe what a rating event could look like coming in from our streaming devices. And show ID is 0 and rating is 10. So someone rated whatever show has ID 0, they rated it 10. We don't really know what show that is, though. So we've inserted that as JSON. So if I go ahead and preview, it looks like this. Great, nice compact JSON data. And now let's look at our streams. How have they changed? Remember, they were empty before. So now, almost exactly like when I queried the table, I have my column here. And I can manipulate this column any way I want in my select statement. I can dive into these fields. I can do some operations on top of this. But I also have some really critical information about what change occurred to create this. The action was an insert, which corresponds to this. Update means, no, this was not an update. It is a net new addition. And the row ID, which is a hidden field, usually uniquely identifies this row over time. So if I had an update, I could use this row ID to match it to maybe previous values. Stream B, if I were to preview that, looks the same. Okay, great. So right now, we have added a field to this table, and our streams are showing that this field exists. So let's process that field manually. But instead of doing an insert on top of the table, I'm going to do it on top of the stream. So it should be the same data, but we're going to see how things change. So my insert logic is to select the show ID, the title, and the rating from the join of my stream A, my Netflix shows, right order join on stream A, where the ID of the show is equal to the stream A, the raw data's ID right here. And we're accessing that semi-structured. So let me run this really quickly, because I'm curious. That show with ID 0 and rating 10, 10 is perfect in our scenario. What show was that? So let's go into our actual ratings here, which is our clean BI ready table, and preview the data. Okay, my goodness, it's BoJack Horseman, and it does have a rating of 10. That's a perfect score. So we have processed data from a stream, and up till now, you might be thinking, like, why did I need a stream for that? Because I could have just done that on my Netflix ratings event table. But here's where streams really start to get interesting. If we look at the state of the stream A right now, and maybe you can guess what I'm going to show you, it's different. We haven't modified stream A. We've only read from it. But if I look at stream A, it is empty. And this means, for example, I could run this query over and over and never get duplicate data. I'll run it again. No error. And then if I preview in my end results, I don't have a duplicate. This is really interesting, because usually if I ran it against this table, I would have a duplicate, because I'm just inserting. And I'm not doing any sort of like new data check. I don't have a watermark. I'm not doing any predicates. I'm just doing a much more simple to write, which means simpler to maintain and less error prone, insert statement against this stream. Now stream B, on the other hand, I did not read from it. So if I select here, it's still there. And something you might be wondering is, why is stream B not empty every time I mess with it? The reason is, even though we are reading from stream A and stream B, if we don't do any inserts or data modification with the results, the stream will not flush itself out. It's only when we do an insert command or a create table as command, we do these data modifications, where the stream results that were used get flushed from the stream. So this makes it really easy for me to create a stream, examine the data that's in there, decide what a good processing logic approach would be for me, and then only at that point do I start flushing data out of the stream. This is really, really useful if, for example, the ratings events are coming in nonstop. And if you can see from the data, in my scenario, there's no way to identify a new record off the bat. There's no like timestamp, there's no other kind of watermark to use. So this becomes really powerful. Let's insert a couple more ratings here. So show ID 1 and show ID 2. And now we've had some reading from the stream. We've had some inserts to the underlying table. Let's see how things change. I'm going to start with stream B, because this is the record of things that have changed that we haven't processed yet. And so we have them, not really in a particular order here, of the two new records I've added, plus the original one I had. They're all inserts. None of them are updates. And the row IDs here give us that information. Stream A, however, remember I processed show ID 0, that first record we had. So when I show this, it only has those two new records. I am super jazzed and excited about this. If you followed me up to this point, you understand the core of what a stream is and why it's valuable for processing. Your exploratory joins that you might run to get a feel for how to process data now become powerful enough, once you point them to a stream, to be production transformation tools. You don't have to rewrite your logic to accommodate for like data change capture events. So now let's insert, just like we did before, into show A using the same logic where we're going to grab show ID 1 and 2. We process that. Let's preview these ratings. Okay, Ozark and Master of None. We've got 10, 9, 8 for the ratings. They have been processed. I can run this again just like before and not have to worry about duplicate records. This is really powerful, and I haven't had to do any sort of additional logic for that. And now again, when we look at stream A and B, stream A has nothing, and then stream B, of course, has those 3 records. So that's great for append-only stuff, but what if we deleted a record? We found that a rating was fraudulent somewhere. Or here, we're just going to delete all the ratings. Now I look in my rating events. They're empty. And this is where things get super interesting. Stream A is maybe what you would have guessed. Our events are here, but they're deletes. So I can see for this row ID, they've been deleted. And I might have a secondary processing flow, one to insert, where I might add this metadata row ID. And then here, I can look for deletes on the stream and delete from my end result table where the row ID is equal to the deleted row ID. That's maybe a mouthful. I didn't do that here, but you can start to imagine where the possibilities start to get more nuanced for real world use cases. Now stream B, hold on to your hats here. Stream B is empty. This is some sophistication, and it's where you can start to save some real money. For high churn tables where events are added, created, updated, anything like that, the streams are going to collapse unprocessed changes that would cancel each other out. So if we had those 3 records get added and then 3 records get removed before our processing logic came through, we would show no data to process, which would save us from spending compute to process records to insert them when we would just have to delete them a second later. This is really powerful, and it's something that would be hard to implement by hand. I think a lot of us have built this kind of logic on our own. So that's a stream. We have our streams in place, but I don't want to run this command manually. I can't just log in every hour and give it a run. Let's automate this, right? And Snowflake, right built in, has tasks just for this. And the task integration with streams makes this really easy. So I'm going to create or replace a task. In your copy, you're going to have to provide a different warehouse because you'll need one. So tasks are assigned a warehouse to run with. And I'm going to name it Netflix Ratings Event Processor. The schedule I'm using is just running it as frequently as you can, which is every minute in Snowflake, which is not always an appropriate fit for everyone. Don't just default to this. But in our situation, it's a good thing. And it's when the system, so I have a predicate here, it's only going to run and fire up the warehouse when this stream has data. So that's really powerful for me, especially when I have the collapsing behavior. So I can avoid even turning on the task when there's no data to process. This costs no compute for me. And you'll recall our insert, it's the same insert as above. So I'm going to create that task. Now tasks, when they're created, they're off. So you have to resume them. This is to avoid you just spending a ton of money on accident when you didn't mean to. So let's activate the task. Every minute, this is going to check for new data and process it. So let's really quickly add a bunch of new records. And important to note here, I've thrown in a non-conforming schema. So this is platform 9.75, which is not a show rating. Who knows what that means? Will we be able to accommodate this weird piece of data? So I will really quickly preview in our ratings. I'll just run over and over here. We have those originals from before. Remember, I didn't delete them, but we're expecting a couple more. So this is always the most scary part of this presentation, because if I hit the timing wrong, we could wait 60 seconds or more. So I'll give that a second. And then when this data is populated, we're going to really quickly see what the best rated show is on Netflix. I'm excited to see what that tells us. Okay, look, without doing anything manual, I've just waited for the task to run. All of these new ratings have been added to the system. They've been processed, and this will continue processing without me having to work with it. And in real life, we actually do our own Snowflake security monitoring on top of CloudTrail logs using this. So this is something I've set up, I want to say last summer, and I haven't had to touch in a year now. That's how reliable these pipelines can be. So let's real quick select the show title and the average rating from our Netflix ratings table, grouped by the show title and order by descending ratings, limit 1. So what is the best show on Netflix? Oh, I can't believe it. It is BoJack Horseman again. It is the best show. It's also the most highly rated show on Netflix. So please do check out BoJack Horseman while you're checking out streams and tasks. Put it on in the background while you're developing. And that's kind of the demo. I'm going to clean this up. You can clean these up too if you wish, though you'll be fine. Normally a task would run and just run a warehouse nonstop. But because we have this really cool stream catch, it won't bill you anything if you don't add more data to the Netflix space. So I'll clean this up. And if you're interested, I'll save that for later. Let's jump back into the slides. I have just a few closing thoughts, and then we'll open it up to questions. First, streams. They're really, really useful if you're doing non-append-only operations on tables directly in Snowflake. So you would have maybe a billion record transactions table that has updates hitting it directly. It has some deletes. It has all that. This can be a really efficient way to process that. I also want to encourage you to check out change tracking. So this is something you can enable on top of a table that doesn't have the same flushing behavior of streams. And for some people, it gives you the benefits of tracking the metadata that we saw before without having to keep in mind like how a stream will flush or not flush or deal with that state. So change tracking is really a really cool feature. You just alter the table to enable that. Use append-only data ingestion where possible. This is just some advice. So if you're in a scenario where you do have a table like this that's getting updated often and needs to be reprocessed, look at maybe just append-only and then doing some reconciliation on the Snowflake side. I've seen that this works a lot better in my experience, and it's less prone to error than some of these other like change tracking only approaches. And if you're having trouble identifying those, when you do ingest, add an ingestion time. Just using current timestamp, and this allows you to kind of window your data changes. And then you can at any point in time see what the data would have looked like a year ago if you're using this. So this is snapshotting. I'll see a lot of people do it this way, the kind of more hard way, and then after the fact try to implement snapshotting when really it would just be easy to ingest in a snapshot fashion. Next, our tasks. Tasks are awesome, and they could be a little bit better, honestly. Monitoring is really a place where they could be a little bit simpler. And for internally at Hashmap, this is something I was going to share. We actually monitor with the Snowflake metadata. So Snowflake exposes your account usage data directly to you for use any way you like. And so we have here, in some of our other monitoring, we have our runtimes by task. And the Netflix ratings event is really low, but that CloudTrail flattening task I showed you, or I mentioned, we've been running it forever. So this is, I think, the last 30 days of usage, and you can see spikes in median run times, which approximate to cost. And I have this running really consistently. So anytime there's new data to process, I process it right away. So that's cool. If you want to do something more advanced or really try to correlate this exactly to dollars, there are ways to do that. You should definitely check out the Hashmapping blog where we talk about some of that stuff more in depth. One thing to know about a task, and I learned this trying to do administrative stuff in a task, all tasks always turn on a warehouse. So even if your SQL operation doesn't need a warehouse, like you're going to create a user, for example, it will invariably turn on a warehouse. So be aware of that. And I personally would love a future where a task could be powered by like a serverless compute layer where you wouldn't have the 60-second minimum billing. I think that would be super cool. And I love that Snowpipe++ does that for ingestion and will scale up. I think that would be a natural extension. So that's something I wanted to share to the Snowflake people. And thank you. That's all I had. I'd be happy to answer questions now.
All right. Well, thank you. You jammed a lot of information there into that session. I think people are going to have to rewatch your session a couple of times. I think another thing worth pointing out is you did a webinar, I think last month or so, on streams and tasks where you talked about some of the other aspects of it. So you may want to share the link for that as well in the chat with everyone.
Sure.
So bunch of questions. We're not going to be able to go through all of them, so I'll let you answer some of them in the Q&A after. How do streams work if we truncate and load the same data?
Yeah, that's interesting. So the truncate operation shows as deletes in the streams. So if you truncate everything and then reload everything, I think they'll be treated as totally different records. Whereas if you just were to modify or update, they would maintain the history across. So if you did an upsert, for example, the thing with streams, it's kind of mentally confusing for me too, even though I use them. Give it a try. It doesn't really take much to just fire one up and modify an underlying table to experiment a little bit. And then of course the docs have a lot more information. So I'll be the first to admit, I don't have all the non-append only behavior for streams memorized. I personally will only use streams in an append-only fashion. Good question.
All right, I think you answered this one. Does this work on traditional non-variant data types where data is being inserted or updated?
Yeah, absolutely.
I think the interesting part is that you actually showed, before anybody asked, can you do this with semi-structured data like JSON? And you actually showed that, which is a very unique feature across many systems. Let's see. Okay, one more. If we schedule a task for every minute, is it going to charge for warehouse even though there is no data to update?
Okay, so that's an interesting question. Usually, if you don't put in this little part here, let me show you. Man, let me get rid of this zoom thing. In the SQL, we do a thing where the stream has data to run. In that scenario that we've done, it will not charge you. It won't run until there's data to process. But if you're not using a stream and you have a task that's going to be looking for other things to run against, right now, yes, it'll run nonstop. So if you have it every minute, you'll just be running that warehouse all the time. So that's something to look out for because it can be an easy way to spike your billing without realizing it.
Good question and answer, an important one. Well, thank you very much, Randy.